Right, now we are going to start with a chapter called as limits. What is limits? Ideally, when you try to divide by 0, division by 0 is not possible. That means if I were to try to divide any number by 0, I would get infinity or not possible division. Right? Now, in order to, if I still insist that I want to divide by 0, a method was evolved wherein instead of dividing by 0, you would divide by a number close to 0. So instead of dividing by 0, if I divide this by 0.00001, I would be dividing by approximately 0 and my answer would be close to the original answer since I am dividing approximately by the same number. And this is what is called as limits. What is limits? Where when division is not possible by 0, you divide by a number close to 0 so that you can get an answer instead of getting a meaningless equation. Let us start with the sums. Now there are multiple types of sums that you have in limits. Type 1, this is called as the direct method. Type 1, this is called as the direct method. Now, let's see this. Limit of x tends to minus 1, 2x cube plus 5 upon 3x minus 6. Right? Now, when you have this, first thing that you have to do is try to substitute the value of x in the denominator and check if the denominator is 0. If I substitute x as minus 1 in the denominator will not be equal to 0. So what we do is we directly substitute. So in this case this will be 2 into minus 1 the whole cube plus 5 upon 3 into minus 1 minus 6 minus 2 plus 5 minus 3 minus 6, that gives you 3 upon minus 9 minus 1 upon 3. This is called as direct substitution. Right? Let us try another sum of this kind. Limit of x tends to 2, root of 2 plus x minus 2 minus x upon x. Right? Again, substitute the value of x as whatever value is given, 2 in the denominator, and check if the denominator is 0. If the denominator is not 0, you can do direct substitution. Here, if I substitute x as 2, the denominator will not be 0. So limit of x tends to 2, this will be 2 plus x minus 2 minus 2 plus 2, 2 minus 2 upon 2, this is square root of 4 minus 0 upon 2, 2 upon 2 which is 1. Fine. Let us see another sum, guys. Limit of x tends to minus 2, 3x square plus 5kx minus 11 is equal to minus 29. Right? Now in this case, since there is no denominator, I can directly substitute. So this is going to be 3 into minus 2 the whole square plus 5k into minus 2 minus 11 is minus 29. This is 4 3s are 12 minus 10k minus 11 is minus 29. This is 1 minus 10k is minus 29 minus 10k, take the 1 on the other side, is minus 30, k is 3. So this is your type 1, wherein what you have to do is you have to just substitute the value. Now in all these cases the denominator was not equal to 0. what if the denominator is equal to 0? That's what is your second type. Now let's see how do we do this. The second type is called as simplification. The second type is called as simplification. Let us see the sum. Limit of x tends to a upon b, b upon a minus bx plus a upon bx square minus ax. Fine. Now in this case, if I substitute the value of x as a upon b in the denominator will be equal to 0. So I have to first factorize this and cancel a term in the numerator and denominator. Only after I cancel a term in the numerator and denominator will I be able to substitute the value of x. So let's see how do we do this. This can be written as limit of x tends to a upon b, b upon a minus bx plus a upon, I could take minus x common, in which case this will become a minus bx. Why? Because minus into minus will give you plus, plus into minus here, this minus into plus will give you minus here. Now in this case, this is limit of x tends to a upon b, this is b upon a minus bx minus plus into minus minus a upon x a minus bx. Once you have this, take LCM of the denominator. This is going to be equal to x a minus bx. Since there was a x less here, you will multiply the numerator by x. This will become bx minus a. This is limit of x tends to a upon b. This is going to be, take minus sign common, a minus bx upon x a minus bx. A minus bx in the numerator and denominator gets cancelled. Once you cancel, you need not write the limit anymore. This is going to be minus 1 remains in the numerator. In the denominator, I can substitute the value of x as a upon b. So my answer is minus b upon a. That's how you do a simplification sum. Let's see another sum, guys. Limit of x tends to 3, 1 upon x minus 3 plus 9x upon 27 minus x cube. Right? Now here this can be written as limit of x tends to 3, 1 upon x minus 3 plus 9x, same thing that we did in the previous sum. You could take minus sign common. So in that case this will be x cube minus 27 can be written as 3 cube. This can be written as limit of x tends to 3, 1 upon x minus 3 plus into minus and minus 9x upon x minus 3 x square plus 3x plus 9. I'm using the a cube minus b cube formula. A cube minus b cube is a minus b, a square plus ab plus b square. This is going to be plus 9. Okay. Now here this can be written as, take LCM. So this is limit of x tends to 3. My common denominator would be, or the LCM denominator would be x minus 3 x square plus 3x plus 9. Right, so in this case this will be x square plus 3x plus 9 minus 9x. This is limit of x tends to 3. This is going to be x square minus 6x plus 9, 3x minus 9x, guys. This is x minus 3 x square plus 3x plus 9. This can be written as limit of x tends to 3. X square minus 6x plus 9 is nothing but x minus 3 the whole square upon x minus 3 x square plus 3x plus 9 square and x minus 3 in the numerator and denominator gets cancelled. Once they get cancelled, you can substitute. So this will be 3 minus 3 upon 9 plus 9 plus 9. Answer is 0. Right? Let's see one more sum. Let's see one more sum of simplification type. Limit of h tends to 0, x plus h the whole raised to minus 2, x raised to minus 2 upon h. Now, whenever you have a negative indice, the first thing that you have to do is convert the negative indice into positive indice. Fine. So this can be written as limit of h tends to 0, 1 upon x plus h the whole square minus 1 upon x square upon h. LCM, limit of h tends to 0, x square minus x plus h the whole square upon h into x square into x plus h the whole square. What I have done, I have taken LCM and I have taken the common denominator down. Now this can be written as limit of h tends to 0, x square minus expand a plus b the whole square, a square plus 2ab plus b square upon, don't touch the denominator, let it be as it is for the timing, x plus h the whole square, open the brackets, this is limit of h tends to 0, x square minus 2xh minus x square upon h, x square x plus h the whole square, x square and x square gets cancelled, limit of h tends to 0, I could take minus h common in the denominator, in which case you will get 2x plus h upon h, x square x plus h the whole square, h and h gets cancelled in the numerator and denominator. Once you cancel in the numerator denominator, you can substitute the value. So in which case this will be 2x plus 0, x square x plus 0 the whole square. Remember, you keep writing the limit till the time you don't cancel the numerator denominator. You do not write limit only after you cancel the numerator and denominator. 2x upon x square into x square. So this is 2 upon x cube. Fine. Let's see another sum of simplification. Okay, we are through with simplification. So that was type 2 wherein you simplify. Let's move on to type 3, right? Now in type 3, we will be rationalizing. Question, sir, how do I know I need to use a different type? In rationalizing, there will always be a square root sign. So whenever there is a square root sign, you need to rationalize. Let's see, rationalize. Limit of x tends to 0, root of a plus x minus root a upon root x root of a plus x. Right? Now there is a square root sign in the numerator and there is a square root sign in the denominator. In which case, what you have to do is, you will be rationalizing the numerator. Why the numerator and why not the denominator? Because there is an addition subtraction sign. You have to rationalize where you have addition subtraction sign, not where you have multiplication sign. So I'm going to rationalize the numerator. So this is going to be limit of x tends to 0, root of a plus x minus root a upon x root of a plus x. Let's rationalize the numerator, people. So this will be a plus x plus root a upon a plus x plus root a. Now, the numerator is in the form a minus b, a plus b. A minus b, a plus b is nothing but a square minus b square. So this is going to be equal to root of a plus x the whole square minus root a the whole square. The denominator as it is, let's leave the denominator as it is, x root of a plus x into root of a plus x plus root a. Square and root gets cancelled, square and root gets cancelled. So this is going to be limit of x tends to 0, a plus x minus a upon x root of a plus x root of a plus x plus root a minus a plus a in the numerator gets cancelled. Now I have a x in the numerator, I have a x in the denominator. Since there is a multiplication sign here, I can cancel the x in the numerator and the denominator. Once I do this, I can substitute the value of x. So this will be 1 upon root of a plus 0 into root a plus 0 plus root a. So this is going to be 1 upon a into a square. Root of a square is a. Root a plus root a is 2 root a. So my final answer is 1 upon 2a root a. Right? That's how we rationalize people. Fine, do we get this thing clear? Let's move on to the next sum, guys. Limit of x tends to a, x minus a upon x root x plus minus a root a. Same method, guys. All we need to do is just rationalize. Limit of x tends to a, x minus a upon x root x minus a root a. What am I going to do here? I am going to rationalize the denominator here, people. So let's rationalize the denominator. If I rationalize the denominator, this is going to be x root x plus a root a upon x root x plus a root a. Now, this is going to be limit of x tends to a, x minus a, leave the numerator as it is, x root x plus a root a upon, now this is in the form a minus b, a plus b, so a square. So this is x root x the whole square minus a root a the whole square. This can be written as limit of x tends to a, x minus a, x root x plus a root a upon, this is going to be x square, root x the whole square is x. So x square into x is x cube minus a cube, right? So this is going to be limit of x tends to a, x minus a, x root x plus a root a upon x minus a, x square plus ax plus a square. What did I do here, people? I used the formula a cube minus b cube. That's a minus b, a square plus ab plus b square. X minus a in the numerator and denominator gets cancelled. So all you have to do now is just substitute the value. A root a plus a root a. I'm substituting the value of x as a square plus a square plus a square, 2a root a upon 3a square. A and square gets cancelled. Now this root a cancels with this to give you a root a in the denominator. right? So your answer will be 2 upon 3 root a. Fine. Let's move on to the next sum, people. Limit of x tends to 4, x raised to 4 minus 64x upon root of x square plus 9 minus 5. A rather important sum. Simple, easy sum. I have a square root sign in the denominator, so I need to rationalize the denominator. So this is going to be equal to limit of x tends to 4. I could take x common in the numerator, so this will be x cube minus 64 upon root of x square plus 9 minus 5, rationalizing. Root of x square plus 9 plus 5 upon root of x square plus 9 plus 5. This can be written as limit of x tends to 4, x cube minus 64, leave the numerator as it is, root of x square plus 9 plus 5 upon, in the denominator, this is in the form a minus b, a plus b. Same thing, a square minus b square, so this will be x square plus 9 minus 25. So this can be written as limit of x tends to 4, x. Now my numerator, we'll still leave it as it is for the timing. 64 can be written as 4 cube. This is root of x square plus 9 plus 5 upon x square minus 16 plus 9 minus 25 is minus 16. Minus 16 I'm going to write as minus 4 square. Now this can be written as limit of x tends to 4, x, use the formula a cube minus b cube. So this is going to be a minus b, a square plus ab plus b square, right, into root of x square plus 9 plus 5 upon, this is in the form a square minus b square. So this is going to be a plus b, a minus b. X minus 4 cancels in the numerator and denominator, in which case substitute the value of x as 4. So 4 square plus 4 square plus 16 plus 9 plus 5 upon 4 plus 4. This is 4, 16, 32, 48 into 48, 16, 5, 25, square root of 25 is 5. So 5 plus 5, 10 upon 8, 6 are 24, 240 is the answer. Right? Next, let's move on to the next sum, people. Limit of x tends to 0, root of 2 plus x minus root of 2 minus x upon root of 3 plus x minus root of 3 minus x. Here we have a square root sign both in the numerator as well as the denominator. Since I have a square root sign both in the numerator as well as denominator, what I would have to do here is I would have to rationalize both the numerator as well as the denominator. Fine. Let's see this. This can be written as limit of x tends to 0, root of 2 plus x minus 2 minus x. Let's write the sum first. Root of 3 plus x, 3 minus x into, first let's rationalize the numerator. So this will be 2 plus x minus 2 minus x. So plus, this was minus sign, so this will be plus upon square root of 2 plus x plus 2 minus x Also, let us rationalize the denominator. So this is going to be root of 3 plus x plus root of 3 minus x upon root of 3 plus x plus root of 3 minus x. This can be written as limit of x tends to 0, a minus b, a plus b, a square minus b square, right? This is going to be this, and the other denominator remains as it is, 3 plus x plus 3 minus x upon, in the denominator, a minus b, a plus b. So this is going to be a square minus b square. The remaining denominator as it is, root of 2 plus x plus root of 2 minus x. This can be written as limit of x tends to 0, 2 plus x minus 2 plus x, root of 3 plus x plus root of 3 minus x upon, this is 3 plus x minus 3 minus into minus plus x into root of 2 plus x plus root of 2 minus x. Now here plus 2 minus 2 gets cancelled, plus 3 minus 3 gets cancelled. This is limit of x tends to 0, x plus x 2x into root of 3 plus x plus root of 3 minus x upon x plus x 2x root of 2 plus x plus root of 2 minus x. 2x cancels in the numerator denominator. All I need to do is substitute the value. So in this case this will be root of 3 plus 0 plus 3 minus 0 upon 2 plus 0 plus 2 minus 0, root 3 plus root 3 upon root 2 plus root 2, 2 root 3 upon 2 root 2, answer is root 3 upon root 2. Thus we have finished three types today. We finished direct method, we've done factorization or simplification, and we've done rationalization. Next session we'll move on ahead, right? Let's stop here for the day, guys.